Hello everyone, welcome to Dakshana e-classroom program. So today we are going to start a new topic, and that is basically about optics, and we are going to look at optics from different angle, and that is basically its wave nature. तो उससे पहले आपने ज्योमेट्रिकल ऑप्टिक्स पढ़ रखा होगा, उसमें आपने देखा कि कैसे चीज़ें लाइक मेनली वी स्टडी टू फेनोमेनास देयर लाइक दैट इज रिफ्लेक्शन डिफ्रैक्शन डिस्पर्जन आल्सो थ्रू द प्रिज्म. सो वो सब चीज़ें अपन वहाँ पे स्टडी किए और लाइक आपने देखा उसमें चीज़ें कैसे क्या डिफरेंट टाइप्स के प्रॉब्लम वगैरह. दैट वाज बेसिकली ऑल अबाउट योर ज्योमेट्रिकल ऑप्टिक्स. नेक्स्ट थिंग इज़ लाइक सेम ऑप्टिक्स मीन्स इट्स अबाउट लाइट, इज इट्स. तो लाइट के बारे में ही चीज़ें थोड़ा सा, बट उसको हम डिफरेंट एंगल से मीन्स इट्स वेव नेचर अपन यहाँ पे समझेंगे. सो बिफोर गोइंग टू स्टार्ट विद दैट टॉपिक और दैट चैप्टर, आई एम गोइंग टू टेल यू समथिंग एक्चुअली वेरी इंटरेस्टिंग अबाउट दिस optics, or you can say wave optics. Do you know actually for the first time who started studying or research and knowing the behavior of light? Let me tell you, the answer is simply it's Newton actually. Around 1670 or 1660, Newton studied a lot about light, and he gave, based on his research and his studies, he gave one theory, and we call that as Newton's corpuscular theory. In that theory, Newton actually considered light as particle nature. तो न्यूटन ने लाइट को पार्टिकल नेचर मान करके न्यूटन ने कहा कि लाइट है वो बहुत छोटे छोटे पार्टिकल से बनी हुई है, और उन पार्टिकल को ही उन्होंने न्यूटन ने नाम दे दिया कॉर्पस्कल्स. एंड दैट थ्योरी इज टर्म्ड एज न्यूटन्स कॉर्पस्कुलर थ्योरी. वो क्या थी, आई विल राइट दैट टू आल्सो, लाइक लेट मी जस्ट एक्सप्लेन यू फ्यू थिंग्स. तो उसमें उन्होंने बोला कि जो लाइट है पार्टिकल से बनी हुई है, उन पार्टिकल्स को, बहुत छोटे पार्टिकल्स हैं, उनको हम कॉर्पस्कल्स बोलते हैं. द थ्योरी इज टर्म्ड एज न्यूटन्स कॉर्पस्कुलर थ्योरी. उन्होंने एक्सप्लेन किया कि लाइक जो डिफरेंट कलर्स होते हैं लाइट के, दैट इज़ बिकॉज डिफरेंट पार्टिकल्स हैव डिफरेंट साइजेज. जो पार्टिकल्स हैं दे ट्रैवल विद द स्पीड ऑफ लाइट, ट्रैवल इन द स्ट्रेट लाइन. Newton was able to explain the phenomena of reflection and refraction. Reflection he explained by considering the elastic collision of the particles, is it, on the reflecting surface. तो जैसे कॉलिजन में अपन देखते हैं एग्जैक्टली एंगल ऑफ इंसिडेंट, जितने एंगल से आती है बॉल उतनी एंगल से जाती है, एग्जैक्टली उसी तरीका से न्यूटन ने रिफ्लेक्शन को एक्सप्लेन कर दिया बाय कंसिडरिंग द पार्टिकल नेचर ऑफ लाइट. न्यूटन ने और भी चीज़ें बोली कि जो refraction है, basically when the light is traveling from one medium to another medium, light bend towards, is it, one medium, or bend towards the normal when it is traveling from rare to denser medium. He explained that by considering that the heavy particle or the particles in the denser medium attract the light particles more, and that's why they bend. He also told actually that in the denser medium, light travel at faster speed compared to the rare medium. That was proved completely wrong later on actually. So this was like theory of Newton, and we call that Newton's corpuscular theory. He explained a lot of things like very well, and the theory prevailed, like everyone was like believing in that. And at that time actually Newton was just like God, because actually everyone knows he is a very big scientist, or sorry, I mean like he was a great scientist. He did lot of research. न्यूटन ने बहुत सारी चीज़ें की, और like everybody was believing that yes, he whatever he is doing everything is like right. So that's why in same way actually Newton's corpuscular theory was also like widely appreciated. Everybody was like believing in that and knowing that okay, Newton whatever he is saying all that is right, and he was even proving a lot of the things with that theory, and that was found to be right. At the same time, there was another scientist, that name is Heisen. Almost like parallel, you can say. He looked at this like light from different angle, and he thought that light may have wave nature instead of particle nature. He was not agreeing basically with the Newton. He thought like Newton is not right, whatever Newton is saying that is not correct. He was thinking light may have some like wave nature actually. But the point was, because everybody was believing in Newton, so that's why the theory of Heisen was dumped actually for around a century. Nobody was even interested in like look at that Heisen's theory. It was around 1801 when Thomas Young, one scientist, was there. Actually, he did one experiment that we will study, and that is Young's double slit experiment. That was the phenomena actually of, like, we will see that interference phenomena. Is it this interference phenomena, or we can say the Newton's corpuscular theory completely failed to explain that interference phenomena, or that double slit, Young's double slit experiment. From that point of time, people started thinking back about the Heisen's theory, maybe like because Newton's corpuscular theory was completely failing. It was not at all giving any explanation, any result for Young's double slit experiment. Then people started thinking maybe Heisen was saying, maybe that was something right actually. Maybe with the help of that we can understand this interference phenomena, or that experiment by Thomas Young. So then actually that was like one of the strongest evidence, or one of the observation that basically forced scientists or people to think from different angle other than Newton's corpuscular theory. And then basically that one experiment, then people started Heisen's principle, and then that comes actually. So then people thought, okay, now Newton was actually wrong, and now light is having wave nature, because wave nature was explaining the interference phenomena, later on diffraction phenomena. All those things were explained by wave nature of light. And Heisen's theory, we will see that also. What is exactly Heisen's theory? Heisen's theory से अपन law of reflection and refraction को भी समझ सकते हैं. So इसके बाद now it was proved that light is having actually wave nature. Even later on many more experiments were done actually. Fresnel did lot of diffraction experiment. All those incident observations were supporting the wave nature of the light. In around 1860, Maxwell's also gave the theory of electromagnetic wave, that was also supporting the wave nature of the light. So all those things actually supporting, and everybody was now believing that light is having actually wave nature. And then story was not still over. There comes one twist actually. Around 80, or basically you can say 1900, there comes one more observation, Hallweg's and Lenard's observation, and that we call basically photoelectric effect. Hallweg and Lenard's observation was that when light is incident on some metal surface, some electrons are ejected from that metal surface, and the kinetic energy of those electrons is not depending on the intensity of light, because you have studied already string wave, sound wave. So means wave you have studied. If you remember the things from there, then intensity actually is directly proportional to the amplitude square, and you can say the energy is proportional to amplitude square or intensity. So higher energy means higher intensities. That implies if wave nature is still true, or if wave nature is still able to explain that Hallweg and Lenard's observation, then according to that, when higher intensity light is falling on the metal surface, the ejected electrons must have higher kinetic energy, but this was not actually observed. So that's why here again comes twist, and the point is that wave theory of light also failed to explain Hallweg and Lenard's observation, or I will say the photoelectric effect. This photoelectric effect and Hallweg and Lenard's observation we will study again in detail completely. That will comes under modern physics. There we have a chapter that is called photoelectric effect. तो वहाँ पे अपन इसको समझेंगे भी कि कैसे जो वेव नेचर ऑफ लाइट है वो किस तरह से फोटो इलेक्ट्रिक इफेक्ट को एक्सप्लेन करने में पूरी तरह से फेल हो जाता है. सो दैट एक्सपेरिमेंट वाज अराउंड इन 1900 year. There comes another very big and scientist everybody knows, and that was Albert Einstein. So Albert Einstein in 1905 was able to explain that photoelectric phenomena by considering the particle nature of light. He basically gave a new term that is termed as photon. So basically he gave like a theory that light is actually consisting of very small packets of energy, and that he termed as photons. With the help of that theory, he was perfectly able to explain the photoelectric effect. So there comes like initially Newton suggested it is particle nature, then it comes wave nature of light, then in 1900s like year again there comes like because photoelectric phenomena was not explained by wave natures, then Einstein explained it by particle nature. Then later on actually scientists like gathered and they finally reached on like conclusion that actually light has dual nature, and this dual nature of the particle and all other things, I mean like later on de Broglie did like with the consultation with Einstein, he gave another theory that actually everything or even particle also has dual nature. This part also we will study again in modern physics, and you will study this part dual nature of like matter or particle in your chemistry also. So, and we will study in modern physics. So this was actually all stories. So finally like we reached the conclusion that light has dual nature, and later on it was also like extended to other objects, that everything in the universe has dual nature, is it? So we will see this part also, that how things has dual nature. We will also see in modern physics that how even like experimentally we were able to prove. We will see there is one experiment, Davison and Germer experiment, which experiment actually proved the dual nature of electron. We will see that experiment also in modern physics. So things are actually very interesting. You can like imagine how story is going forward, is it? And so this was all basically story about light, and finally we are in right now considering that light has dual nature. Few phenomena we can understand with the particle nature of the light, and some other phenomena can be understood only with the wave nature of light. So the wave nature able to explain like interference, diffraction, all these phenomena we can understand by wave nature. Polarization also, reflection and refraction you can understand with the particle nature also. So now this was all story about light, is it? I hope you like it. It's interesting thing. Now we are going to see about the wave nature of light, because I can say the ray optics, you can say it's the sort of like more of particle nature of light that you have already finished. तो अभी अपन यहाँ पे समझने वाले हैं कि न्यूटन्स की कॉर्पस्कुलर थ्योरी, जस्ट few points कि क्या थी थोड़ी सी, और I will write that. Then we will see what was Heisen's principle. Heisen ने लाइट को exactly किस एंगल से देखा, क्या थ्योरी थी, क्या चीज़ें थी like, and how Heisen's theory was able to prove, or like how with the help of Heisen's principle we can prove law of reflection and refraction. Then we will also see the one of the strongest observation that actually forced scientists to think from the different angle, or to think about light from the wave nature. That was Thomas Young's observation, or that we call Young's double slit experiment. That is one of the most important part in this chapter actually, and this is also one of the most important topic in basically for IIT advanced point of view. In this chapter you will see there are a lot of problems you will find on that topic, Thomas Young's डबल स्लिट एक्सपेरिमेंट. तो ये सब चीज़ें अपन आगे इसमें देखेंगे. देन वी विल आल्सो डिस्कस अबाउट डिफ्रैक्शन एंड पोलराइजेशन फेनोमेना. सो लेट्स कंटिन्यू हियर दिस चैप्टर विद द न्यूटन्स कॉर्पस्कुलर थ्योरी. ओके, सो फर्स्ट थिंग इज न्यूटन्स theory of light. So this theory, like you already I just now explained, actually Newton considered actually that Newton considered that light is of very small particles. He named them corpuscles. Right? These corpuscles travel with the speed of light in straight line with the speed of light. These were all observations of Newton and that we are going to study as Newton's corpuscular theory of light. So this and that. Newton also told different colors are because of different size of corpuscles. जो लाइट का अपन देखते हैं, वाइट लाइट इज कंसिस्टिंग ऑफ 7 कलर्स ब्रॉडली, तो वो जो अलग अलग कलर हैं उनके लिए न्यूटन ने एक्सप्लेनेशन दिया था कि जो पार्टिकल्स हैं उनका साइज अलग अलग होता है, उसकी वजह से लाइट के डिफरेंट डिफरेंट कलर्स होते हैं. सो दैट वाज Newton was able to explain the law of reflection. Law of reflection was explained by elastic collision of these particles with the reflecting surface Newton also about refraction he told actually law of refraction. For this he told light travel in denser medium with higher speed and particles of denser medium attract more, is it? These corpuscles that result in bending of light. न्यूटन ने बोला कि जो लाइट है जब डेंसर मीडियम में ट्रेवल करती है, first thing he told was that actually the speed of light in denser medium is more compared to rare medium, and the particles of denser medium attract the light particles higher, and that's why that result in bending of lights. That's way like how Newton was able to explain the phenomena of law of reflection. Refraction, that actually this statement was actually right or is right. We know that speed of light in denser medium is actually low, is it? But this was observation of Newton on Newton's corpuscular theory. So these were few things actually about Newton's corpuscular theory that later on like failed to explain, but it also has important because from here actually things started about light, is it? Then we are next going to see the Heisen's principle, because here this was over, we can't understand the things or the wave nature of light with this help actually, but this was about Newton's corpuscular theory. So let's see next Heisen's principle or Heisen's theory of light. Okay, next thing we are going to see is Heisen's principle. So actually Christian Heisen was the first scientist to propose the wave nature of light. That was almost parallel to the Newton's corpuscular theory, but this theory was almost dumped for a century until like Thomas Young came with the observation with his experiment of double slit. Okay, so we are going to see what exactly was Heisen's principle. The point is, it's totally different. It's like completely new, but you try to look at it, try to understand what was the theory actually. So look at it just a theory. Okay, like Heisen has some different understanding of light. उन्होंने कुछ अलग ही तरीके से लाइट को सोचा. क्या सोचा था, कैसे सोचा था, कैसे चीज़ों को उन्होंने एक्सप्लेन किया, हम उसको अभी समझने वाले हैं, है ना. सो फर्स्ट थिंग इज, पहले यहाँ पे इससे पहले ये भी चल रहा था कि हाइजन ने बोला लाइट इज एक्चुअली ए मैकेनिकल वेव. इज इट? देन इफ लाइट इज मैकेनिकल वेव, देन to travel the light, because for traveling a mechanical wave a medium is required. Then scientists ask, like, if light is mechanical wave, then how light travel from sun to earth? Because people were thinking like there is, earlier this was the discussion that there is people were not knowing, or scientists were like thinking, I think like there is nothing actually. Then Heisen explained that by saying that actually the space between sun and earth is filled by some hypothetical medium, and he termed that medium, or like he simply said it is, there is some medium, some, this all space is filled by some medium, and he defined that, he termed that medium as ether. तो हाइजन ने बोला कि जो मीडियम है वो ईथर भरा हुआ है पूरे स्पेस में, जिसमें से लाइट ट्रेवल करके आती है. बिकॉज फॉर मैकेनिकल वेव it is must, medium is required. Without medium they can't travel. We know now actually that light is not a mechanical wave, it's an EM wave, electromagnetic wave. Electromagnetic wave क्या है ये भी अपन एक चैप्टर इलेक्ट्रोमैग्नेटिक वेव के नाम से है. वी विल डिस्कस इन डिटेल द प्रॉपर्टीज ऑफ इलेक्ट्रोमैग्नेटिक वेव एंड हाउ इट ट्रैवल इवन थ्रू स्पेस, इवन थ्रू वैक्यूम एक्चुअली. ओके, सो दैट is the like current research, current result, that actually Heisen was not right about the mechanical nature of wave nature of the light. But yes, Heisen was the first to propose the wave nature of light. Is it? Was the first of light, and light is actually a mechanical wave which travel from sun to earth through a medium he called that ether. So ether is that medium which is actually filled in the space between earth and sun, जिसके थ्रू लाइट ट्रेवल करके आती है. Okay, this was just like something about Heisen's principle. But Heisen's principle क्या था exactly, अभी वो समझते हैं, है ना. तो Heisen ने इसको एक अलग एंगल से देखा, and that angle was focus it here properly. It's interesting, or because it's completely different, so you may find, if you are not understanding it properly, then you may find it difficult also. So he's told actually that light is a wave. What is wave? Wave is a disturbance actually which propagates through a medium. इज इट? इससे पहले आपने साउंड वेव और स्ट्रिंग वेव पढ़ रखा है, तो आपको वेव का मतलब क्या है ये आपको समझ में आना चाहिए। वेव क्या होता है? एक डिस्टर्बेंस होता है जो एक मीडियम के थ्रू प्रोपेगेट करता है। तो यहाँ पे क्या होता है, एक सोर्स होता है विच जनरेट दैट डिस्टर्बेंस। जैसे सिंपल सा एग्जांपल आप समझ सकते हैं, लेट्स से देयर इज सम water body, some like talab, some pond, and if you're dropping one stone in that pond, actually then it generates some water ripples, and that we call basically wave, is it? तो उस केस में आपने देखा होगा कि जो रिपल्स जनरेट होती हैं पॉन्ड तालाब में, वो इस तरह से सर्कुलर रिपल्स जनरेट होती हैं। यहाँ पे जो पार्टिकल हैं वेव like water, is it, that vibrate, oscillate like that, and wave spread it even in bigger and bigger circles actually. तो ये क्या हो गया, एक source, the stone which is dropped in the pond is a source of disturbance, and this disturbance we call that wave. Similarly, Heisen told that a light source is a basically disturbance, is it? I'm like source is generating that disturbance, and this disturbance propagate through the medium, is it? तो अब ये डिस्टर्बेंस क्या हुआ, एक मीडियम से प्रोपेगेट कर रहा है। Heisen told that actually when this disturbance is passing through a medium, correct, मीडियम से पास कर रहा है, then every particle of this medium will act like new source of disturbance. Listen it carefully because this is the theory. हाइजन ने कहा कि जो लाइट का सोर्स है वो एक डिस्टर्बेंस क्रिएट कर रहा है। दिस डिस्टर्बेंस इज प्रोपेगेटिंग थ्रू द मीडियम, राइट? और he defined a new term that is called wavefront. Okay, so let me tell you that one also. Wavefront. Wavefront क्या है? Locus of all the particles oscillating in same phase are at same distance from source. Especially for this case actually. वेव फ्रंट उसने क्या कैसे डिफाइन किया हाइजन ने, कि वेव फ्रंट क्या है, लोकस ऑफ ऑल द पॉइंट्स विच आर ऑसिलेटिंग इन सेम फेज। सेम फेज का मतलब आई होप यू आर रिमेंबरिंग फ्रॉम द स्ट्रिंग वेव और साउंड वेव। Even if you are not remembering, no need to worry, I will explain all those things just now, is it, after this part, because for like Young's double slit experiment we will need all those things, but this part you can understand even here, like if you know the just term. तो यहाँ पे क्या होगा, ये एक डिस्टर्बेंस हो गया और एक सोर्स हो गया जो कि डिस्टर्बेंस जनरेट कर रहा है। नाउ दिस डिस्टर्बेंस इज प्रोपेगेटिंग थ्रू द मीडियम। तो ये सोर्स से सेम डिस्टेंस पे ये कुछ पार्टिकल्स होंगे जो क्या होंगे एक साथ, यहाँ पे आप देख सकते हो एक सर्कुलर रिपल्स बन रही हैं। तो एक सर्कल क्या है, दिस वन सर्कल यू कैन से दिस इज वन वेव फ्रंट, राइट? जो वाटर बॉडी में अगर आप स्टोन ड्रॉप करते हो, इज इट, then these ripples are generated. तो ये ripples क्या होंगे, जो सब एक साथ ऊपर जाएंगी एक साथ नीचे जाएंगी, and they are actually vibrating or oscillating in same phase. So that's why the locus of all these basically points which are in same phase, I will say them wave front. तो ये क्या हो गया, वेव फ्रंट हो गया। तो यहाँ पे हाइजन क्या बोलते हैं, सोर्स है, सोर्स से डिस्टर्बेंस जनरेट हुआ, दिस डिस्टर्बेंस इज propagating in the medium. When this disturbance passes through the medium, the particle, is it, तो मान के चलते हैं कि डिस्टर्बेंस यहाँ पहुँच गया, तो अगर ये सभी पार्टिकल सेम फेज में एक साथ ऊपर एक साथ नीचे जा रहे हैं, तो ये क्या होंगे, दिस विल फॉर्म ए वेव फ्रंट, करेक्ट? नाउ वेव फ्रंट व्हाट, लाइक दिस इज जस्ट collection of particle, right? All particles. So now what is happening when this disturbance is passing or reaching these points actually, then each point on this wavefront is also acting like secondary source of disturbance, right? Remember it, this is the theory of Heisen's actually. So Heisen say when this disturbance is reaching like this point, then every point on this basically wavefront will act like new secondary source of disturbance, and this will start generating new wavefront. We call them wavelets. These are called wavelets. Right? I will write the definition. Then what he's told Heisen actually, that disturbance started from here, it travel spreaded actually, is it मूविंग. लाइट अगर यहाँ पर है तो ये क्या होगा, लाइट का एक पॉइंट सोर्स है तो यहाँ से सब डायरेक्शन में लाइट जाएगी आपकी. तो लाइट अभी यहाँ पे पहुंची है तो यहाँ पर क्या होंगे कि ये सभी पार्टिकल्स क्या होंगे सेम फेज में, सो दैट्स व्हाई दे आर कंस्ट्रक्टिंग और फॉर्मिंग वन वेव फ्रंट. तो जो वेव फ्रंट के सभी पार्टिकल होंगे वो पार्टिकल क्या होंगे, एक नए सोर्स की तरह काम कर रहे हैं, वो नया सोर्स की तरह काम कर रहे हैं. नाउ दे आर जनरेटिंग न्यू सेकेंडरी वेव फ्रंट जिनको एक्चुअली में अपन वेवलेट्स बोलते हैं. दिस इज द जो ओरिजिनल वेव फ्रंट बोलते हैं, जो ओरिजिनल सोर्स से आ रहा है. जो सेकेंडरी सोर्स हैं, इज इट every particle on this wavefront is acting like a new secondary source of disturbance, and this is also generating secondary wavefronts. We call them wavelets. Now what is happening, so like मान लिए कि कुछ t टाइम पे ये wavefront इस सोर्स का यहाँ पहुँच चुका है, then how we will say, because like next another will be like locus of all the particle which are oscillating in the same phase, तो एक नया wavefront आएगा. then next wavefront is actually a common tangent to all these wavefronts in the direction of wave. तो डायरेक्शन ऑफ वेव मतलब वेव यहाँ से इधर बाहर की तरफ जा रही है, तो ये जो सभी वेवलेट्स हैं, दिस वेवलेट वेवलेट वेवलेट, इन सभी वेवलेट्स को मैं एक कॉमन टेंजेंट ड्रॉ कर देता हूँ, right, in the direction of propagation of light. This will constitute a secondary, next you can say, wavefront. Is it clear? Okay, no need to worry about original source, first wavefront, and all the particles actually here on this wavefront generating new secondary source, and this is basically जो एक नया वेव फ्रंट की तरह जनरेट करेंगे. इन वेव फ्रंट को अपन वेवलेट्स बोलते हैं. ए कॉमन टेंजेंट टू ऑल दीज वेवलेट्स. अब यहाँ पे कॉमन टेंजेंट देखो, एक ये भी हो सकता है एक्चुअली में, राइट, बट दिस इज नॉट इन द डायरेक्शन ऑफ propagation of light, so this will not give you the wavefront. Next wavefront, first wavefront this, then next wavefront will be this one actually, right. तो इस तरह से क्या होती है, लाइट propagate करते हुए आगे जाती है. This is how actually light travel in the medium. Let me explain it more clear, like more explain like detail so that it's clear to you. And मान लेते हैं कि ये अपना एक सोर्स है, आई एम राइट, यहाँ से डिस्टर्बेंस जनरेट हुआ एंड दैट डिस्टर्बेंस इज ट्रैवलिंग थ्रू द मीडियम पार्टिकल, और एक टाइम पे वो डिस्टर्बेंस कुछ ये पार्टिकल के पास पहुँच जाता है, एंड आई विल से दिस इज लाइक माई वेव फ्रंट, करेक्ट. सो दिस इज वेव फ्रंट. नाउ व्हाट इज हैपनिंग एक्चुअली नेक्स्ट, ईच पार्टिकल, बिकॉज वेव फ्रंट अभी अपन ने क्या बोला, वेव फ्रंट इज द लोकस ऑफ ऑल द पार्टिकल्स विच आर इन सेम फेज. तो मतलब ये वेव फ्रंट क्या है, दिस इज आल्सो कंसिस्टिंग ऑफ लार्ज नंबर ऑफ पार्टिकल्स. तो यहां पर भी क्या है, अपने पास बहुत सारे पार्टिकल्स हैं. तो ये सभी पार्टिकल क्या है, सब एक साथ सेम फेज में ऑसिलेट कर रहे हैं, राइट. This is, so now what happened actually when this disturbance from the original source is reaching these particles, then these particles or particle on or each particle on the wavefront act like secondary source of disturbance. तो अब ऐसे लगेगा ओरिजिनल सोर्स ये था, अब ये भी एक नए सोर्स की तरह काम करेगा, नए सोर्स की तरह काम करेगा. तो अगेन दीज पार्टिकल विल आल्सो जनरेट न्यू डिस्टर्बेंस, न्यू वेव फ्रंट्स, एंड वी कॉल दीज वेव फ्रंट्स एज वेवलेट्स. जो ओरिजिनल सोर्स की वजह से locus of all the particle which are in same phase, we are defining that wave front. हर एक वेव फ्रंट का और वेव फ्रंट का हर एक पार्टिकल एक नए सोर्स की तरह काम कर रहा है, दैट इज आल्सो जनरेटिंग ए डिस्टर्बेंस। उसके लिए जो सभी पार्टिकल होंगे उन सेम फेज में, उनको अपन वेवलेट्स बोलते हैं, राइट। तो यहां पर क्या होगा, ये सभी पार्टिकल्स की वजह से एक नया वेवलेट्स जनरेट होगा लाइक दिस एक्चुअली, राइट। तो ये क्या हो गया, दीज ब्लू कलर्स, दीज आर वेवलेट्स, ओरिजिनल वेव फ्रंट इज दिस। नेक्स्ट थिंग इज ए कॉमन टेंजेंट, बिकॉज अभी क्या हुआ, डिस्टर्बेंस यहां से यहां पहुंचा, अब ये डिस्टर्बेंस आगे जाएगा, इज इट। तो आगे जाएगा तो ये जो वेवलेट्स हैं इनका अगर मैं एक कॉमन टेंजेंट ड्रॉ करता हूं सभी वेवलेट्स का, यहां पर भी होगा, तो ऐसे आप देख सकते हो कॉमन टेंजेंट एक्चुअली में दो आ जाएंगे, कि इधर अंदर वाला कॉमन टेंजेंट, एक बाहर वाला कॉमन टेंजेंट, राइट। सो one common tangent, actually this one, and another common tangent will be this one. Now the common tangent in the direction of propagation of light, और propagation तो wave किधर propagate कर रही है, ये source से दूर की तरफ, so wave is propagating this way, so common tangent is it to these wavelets in the direction of propagation of light means this. So this is the next wave front. First wave front. इस तरह से क्या होगा, next all particles on this wave front will again act like secondary source of disturbance. They will further generate new wavelets. Again the common tangent to all those wavelets will give you next wavefront, and that's how your waves is propagating from source to far away. So this is the theory, this is the how like Heisen is looking at light from different angle, and we call it Heisen's principle. So let me write the terms actually here. So wavefront, I hope it's clear to everyone. wavefront क्या है, वो सभी particles का locus जो एक साथ सेम फेज में वाइब्रेट कर रहे हैं, ऑसिलेट कर रहे हैं, करेक्ट, दैट वी टर्म्स अ वेव फ्रंट। देन नेक्स्ट पॉइंट हियर इज दैट एक्चुअली ऑल पार्टिकल्स इज इट ऑन द वेव फ्रंट act as secondary source of disturbance, एक नए सेकेंडरी सोर्स की तरह काम करते हैं ऑल दोज पार्टिकल, एंड दे फर्दर जनरेट, तो ये सभी पार्टिकल क्या होंगे, फिर से डिस्टर्बेंस सभी डायरेक्शन में जनरेट करना स्टार्ट कर देते हैं, एंड इज इट द वेव फ्रंट to these you can write these new secondary source is called wavelets. तो ये क्या हो गए अपने वेवलेट्स, जो ये नया सेकेंडरी सोर्स उसने भी डिस्टर्बेंस जनरेट किया, वेव फ्रंट, ये इसका जो वेव फ्रंट होगा उसको अपन वेवलेट्स बोलते हैं, राइट। नेक्स्ट पॉइंट इज ए कॉमन टेंजेंट टू these wavelets in the direction of light is the नेक्स्ट वेव फ्रंट। तो पहला वेव फ्रंट ये था, फर्स्ट वेव फ्रंट, दिस इज फर्स्ट वेव फ्रंट एंड दिस इज द नेक्स्ट, यू कैन से सेकेंड वेव फ्रंट, राइट। Actually there will be infinite number of wavefronts, because there will be at every point there will be particle or oscillating in same phase. But if I am considering this is my first wavefront, then this is like we can say it's my second wavefront actually. तो इस तरह से लाइक हाइजन ने लाइट को देखा, एक नई थ्योरी दिया, and that is how actually like Heisen explained, and we call this is Heisen's principle or Heisen's construction. Let me write it more. So actually Heisen's theory was like able to, or I can say Heisen's theory explained the phenomena of interference, diffraction, apart from other reflection and refraction. But this theory failed to explain photoelectric effect and Compton effect. What are these effects? We will see later actually. So this was about, let me discuss more about this wavefront topic, like it's sometime required a little bit more. So let me first erase it. So अभी wavefront अपन को clear हो गया. Wavefront क्या है? Locus of all the points which are oscillating in same phase, or you can say which are, for simple case, which are in like at same distance from the source actually. Next here comes like different wavefronts are possible actually. The shape of wavefront here, so shape of wavefront actually depends on my source, is it? So I can write for a, if it is point source, then you can see if it is a point source, then like wave will propagate in all directions simultaneously, and there will be, if I look at the locus of all the points which are in same phase at same distance, you can just imagine that the wavefront will be spherical. So for a point source you can write the wavefront is spherical. So point source then wavefront, it's a spherical wavefront actually. Similarly if it is a line source, तो यहाँ पे देख सकते हैं कि if let's suppose we have one line source actually, एक light मान लेते हैं, ट्यूब लाइट कंसिडर कर लेते हैं, then it will be generating like light will be emitting in all direction and it will be traveling. तो यहाँ से देख सकते हैं कि सभी particle like locus of all the particle which are in same phase, that will actually like symmetrical like this way. So you can just imagine they will form one cylinder actually. So for a line source, the wavefront will be cylindrical, right? Similarly if we have like one plain source of light actually, just मान के चलो कि ये पूरे like board में अपन छोटे छोटे बहुत सारे LEDs लगा देते हैं, तो क्या like they will be generating, is it, wave, and light will be traveling like parallelly like this way actually. So you can say in that case from this point, this point, this point, this point, all the like locus of all the points basically which are in same phase, so that you can just imagine will be like this plane, is it? So for a plane source, the wavefront will be, तो यहाँ पे आप समझ सकते हैं लाइन सोर्स के लिए, ये अगर अपने पास एक लाइन सोर्स है, then the wavefront will be like cylindrical here, this way. Similarly this, and so on. Correct? Next, अगर अपने पास जो सोर्स है वो एक प्लेन सरफेस है, देन फॉर दैट एक्चुअली प्लेन सरफेस योर वेव फ्रंट विल बी आल्सो पैरेलल प्लेन्स. वेव फ्रंट is, or I can say also parallel plane. तो यहाँ पे आप समझ सकते हैं, let's say this is a one plane source, then here wavefront will be also like this parallel planes, and this way. तो इस तरह से लाइट इस डायरेक्शन में आपका ट्रेवल करेगा, एंड दिस वेव फ्रंट विल बी हियर, लाइक ऑल द लाइक पार्टिकल इन सेम फेस विल कंस्टिट्यूट वन पैरेलल प्लेन्स. तो इस तरह से क्या होता है, लाइक द शेप ऑफ वेव फ्रंट विल एक्चुअली डिपेंड्स ऑन माई शेप ऑफ सोर्स, कि सोर्स कैसा है, on that your shape of wavefront will depend. So this was about actually Heisen's construction or Heisen's principle. Let's see next, with the help of this Heisen's principle, how we can understand, how we can explain the two laws, that is law of reflection and law of refraction. These two proofs that we are going to see is very important from your board point of view. This point Heisen's construction or like Heisen's proof for law of reflection and refraction, not much important from advanced point of view, but important, mainly important, I would say it's almost 100% sure that it will be asked in one of the exam in your like board part. So that is how it's very much important. Let me prove that actually. Okay, so next we are going to see the proof of law of reflection with the from Heisen's principle. Let's see how we can prove that actually, law of reflection. You must be remembering the law of reflection. Angle of incidence is equal to angle of reflection. So let's see that. तो मान के चलते हैं कि ये एक अपने पास reflecting surface है. This is a parallel beam incident. तो यहाँ पे आप समझ सकते हैं कि parallel beam incident has, for parallel beam your wavefront will be what? Parallel plane. So you can say this is your wavefront, this is your wavefront. तो मान के चलता हूँ, let's say v is the velocity of light in this medium. V is it of light in medium, और ये मेरे पास एक पैरेलल इंसिडेंट वेवफ्रंट है. लेट्स से एट t is equal to 0, AB is the incident wavefront. AB अपना इंसिडेंट वेवफ्रंट है. तो अभी क्या हो रहा है, जो अब लाइट है वो यहाँ पे पहुंची है और यहाँ पे पहुंची है, करेक्ट. नाउ व्हाट विल हैपन एक्चुअली हियर, wave has reached, disturbance has reached, but this is the reflecting surface. So now this source, is it, this point will start acting like secondary source, and this will start generating your new wavefronts. We will call them wavelets. So here wavelets will start growing like this. This is your, you can say, reflecting wavelets, correct. Now because it's reflecting in same medium, so definitely like I can write, by the time this started reflecting back, this is still propagating. तो यहाँ पे आप देख सकते हैं कि थोड़ी देर बाद यहाँ पहुँच चुका होगा, थोड़ी देर बाद यहाँ, फिर finally let's say this at some t1 time, okay, let at time wavefront reaches point C. ये मान लेता हूँ जो B का वेव फ्रंट है वो अभी C पे पहुंच चुका है. तो उस टाइम पे यहाँ पे क्या हो रहा होगा, न्यू वेवलेट्स विल बी जस्ट स्मॉल पॉइंट्स, is it, and by this time actually this you can write v into t1, this is the distance v into t1, और उतने टाइम में because it's reflecting in the same medium, so this wavelets or these waves will be like again propagating in same medium, but you can imagine the new wavefront here will be like hemispherical actually, because this will act like a point source. So now what is my reflected wavefront, right? So reflected wavefront will be like, this is my one wavefront, and this is another wavefront. So common tangent to these wavefronts basically will give you a reflecting, or common tangent to these wavelets will give you a reflecting wavefront. तो reflecting wavefront में इनके common tangent अगर draw करता हूँ like this, so this will be like your reflecting, let's say CD. So you can write here CD is reflecting wavefront, right? Here CD, and your reflected light will be like this. Again, parallel beam will be like this, correct? तो अभी अपने पास ये मान लेते हैं, let's say we have two triangles actually here. This one is triangle ABC and another triangle ADC. This angle will be 90 degree, this will be 90 degree, and here if I say, let's say this is normal A and 1 is normal at A, similarly this is and 2, so A and 1 normal to reflecting surface at A, similarly C and 2 normal to reflecting surface at C, correct? यहाँ पे आप समझ सकते हैं this AB is incident wavefront, CD is the reflecting wavefront. This is incident parallel beam, this is reflected parallel beam. यहाँ पे normal. So what I can write, this will be the angle of incident, this will be angle of incident I, angle I. Similarly this will be your angle of reflection, this normal angle of reflection R. तो यहाँ पे देख सकते हो this angle and like angle A, is it this incident wavefront? Now I will say this is I, and you can see this, actually let me write here, this is some A prime B prime. So A prime A B will be your 90 degree angle, angle A prime A B, you can write 90 degree. तो यहाँ पे क्या बोल सकते हैं, ये एंगल अपना A prime A and is angle of incidence I, and this angle I can write, this angle, try to look at it, will be some 90 minus theta, and N prime A N will be on 90 degree, so I can write this angle will be also your angle of incident I. So I can write my angle BAC is also angle of incident I. Similarly, if this is angle N2C, and let me write this is your D prime and this is C prime, so I can write here actually N2C angle N2C C prime, this will be angle of reflection R, and now this is angle of reflection, and you can see this DC, this is 90 degree, so I can write N2CD, this angle will be what, 90 minus R, and N2CA will be 90, so this is 90 minus R, means this is also angle R. This angle will be also R, equal to R. तो अभी अपन ने सिंपली ये देख लिया कि ये एंगल ऑफ इंसिडेंस है, ये एंगल ऑफ रिफ्लेक्शन है, देन दिस विल बी एंगल ऑफ इंसिडेंट. तो यहाँ पे जो मैं ट्रायंगल कंसिडर करने वाला हूँ, दो ट्रायंगल, दोज ट्रायंगल्स आर दिस वन, this triangle, and another triangle is this one, this triangle. So let's consider triangle A, B, C and triangle ADC। अभी अपन ये दोनों ट्रायंगल में देखते हैं और यहाँ पे अपन को ये समझ में आ गया है एंगल BAC is angle of incident or equal to angle of incident and angle ACB is angle of reflection। अभी अपन को प्रूव करना है कि ये दोनों एंगल बराबर हैं, करेक्ट। सो फॉर दैट यू सी एक्चुअली इन these two triangles I can write AC is common to both, and as speed of light in this medium is constant, so that's why I can write जितना time light B से C में जाने लग रहा है, that distance traveled is V T1। exactly I can write same distance will be travels this AD distance is also V T1 because it will be traveling same distance, so this implies I can write AD is equal to BC, those sides, so definitely I can write this implies third side that is equal to BA will be also equal to DC, this implies two triangles are congruent, and if these two triangles are congruent this implies I can write definitely their angles will be also equal correspondingly, so this angle 90 degree, this angle 90 degree, and definitely I can write this angle will be equal to this, right, and this angle DAC will be equal to angle BCA also, so two triangles are congruent, this implies angle of incident will be equal to angle of reflection, and this is your proof of law of reflection कि यहाँ पे दोनों एंगल क्या होंगे, बराबर होंगे। so that you can see actually how easily with the help of like Heisen's principle we can prove actually law of reflection. Let me just explain you a little bit more if you are still having any confusion. See this blue light, this is your parallel incident rays, तो पैरेलल इंसिडेंट रेज है तो इसका जो इंसिडेंट वेव फ्रंट होगा वो A प्राइम B प्राइम, दिस इज सम इंसिडेंट वेव फ्रंट। मान के चलता हूं कि ये वेव फ्रंट मेरा t इज इक्वल टू 0 टाइम पे यहां पहुंच गया, दैट इज AB वेव फ्रंट। नाउ व्हाट इज हैपनिंग बेसिकली, दिस A हैज जस्ट रीच्ड द रिफ्लेक्टिंग सरफेस, B इज स्टिल अवे फ्रॉम द रिफ्लेक्टिंग सरफेस, तो ये आगे बढ़ रहा होगा और ये क्या होगा, एक नया सोर्स वेव फ्रंट है तो इसका ये क्या होगा, एक नया सेकेंडरी सोर्स की तरह दिस विल स्टार्ट जनरेटिंग न्यू वेवलेट्स, तो ये वेवलेट्स सेम बिकॉज मीडियम इज सेम, सो दैट्स वाई स्पीड विल बी सेम। तो अभी इस वेव फ्रंट को B से C पहुंचने में अगर मैंने कहा T1 टाइम लग रहा है, सो दिस डिस्टेंस आई कैन राइट V इंटू T1, तो उतने ही टाइम में क्या होगा, बिकॉज स्पीड इज सेम, दिस वेव फ्रंट और वेवलेट फ्रॉम A might have traveled to D, is it? So this AD distance can be written as also equal to simply AD is also VT1. So now I can write this is just reaching, so thus here wavelet will be just point source and a common tangent to a wavelet at this point and this wavelet at D point. So this DC will be a common tangent and that is giving you reflected wavefront. So reflected wavefront is DC and perpendicular to that, actually perpendicular to this reflected wavefront DC will be your reflected light, is it, or reflected parallel beam। तो ये अपना reflected parallel beam होगी। अभी अपन ने क्या किया, इसमें दो ट्रायंगल कंसीडर कर लिए, this triangle ADC and triangle ABC, and before that we defined this by just simple definition, this is angle of incident, this is angle of reflection. We consider this 90 degrees, so this angle I, then this will be 90 minus I, and this is also 90 degree, so this means this 90 minus I, then this is also I, exactly same manner we reach, this is also I, the R, angle of reflection, and we proved actually by sides that these are congruent triangle, and if these are congruent triangle then I can definitely write my angle of incident will be equal to angle of reflection because these are corresponding angles, and that is your proof of law of reflection. Let's see in the next class, next lecture, law of refraction or proof of law of refraction from Heisen's principle. Thank you so much.